Good morning, people. It's early morning here. Puffy eyes can prove it. Puffy eye. They call me Puffy Eyes, not Puffy Eyes. So, steel. Rod, baby. Rod. Check out that rod. Hard as steel. All right. So, to make the measurements fair, I'm going to use the seam. You see where they press it? And then there's a seam here created on this side and on this side. When they make that deformation to make these ribs, that those seams are created. That's what I'm going to measure across from. So measuring across from that seam, I'm going to slip it off and show it to you, ladies and gentlemen. That's a 3. Huh. Ah. Okay. Oh, wait a minute. Let's turn it that way. Now this has been going on. This experiment's been going on with me for this is around 4th year. And what I did was I painted it with some cheap paint, some dollar spray paint, just spray paint, and like one coat basically. No paint here, and then a different dollar spray paint there, different color. Still dollar, cheap paint. And I wanted to see how much it protected the metal. I think it does a great job, but before I put the paint on it, I let it go this far, and you'll see what I mean by that. That was a 3, right? So now we see yeah, I know I gotta shave. Listen, so now we see the end. They're the ribs here. There's the rib. I guess it's there. See the rib? We had a 3. Let me reset this to 0. Good. 0. Open. And go right at the end there. There we go. I'm rotating it like that so I can make sure where it comes out. Now it's shy. To get to 3, I'd have to come all the way up 4 points. 4 1/1000ths of an inch. Or actually 4,500 1,000ths of an inch. Four point 4.3. So what do we observe here? We observe that when you cut rebar, this has been cut. The cut in wants to deteriorate more, is what I found out. It's weird. It's weird. It exposes a different part of the metal, compresses it or changes it, but you get a different deterioration. Look at that deformation there and all that. That's a straight piece of rod there, so I can't claim that. And I bent it slightly. I bent it slightly so I could see if the bending would create a fracture and create some type of action. But no, and there's your rust scale. Well, actually, it's rust scale, so it's not creating enough pressure yet to do anything unless I do the percentages of it. Let's see if I can get inside one of these ribs. Let me zero it out at the rib. So I can zero this out also, wherever I want to start. And so I'll zero this little caliper out. So now it's at 0. See the 0? Trust me on it. So I'll pull it off. Doesn't matter because 0 is my starting point. And I'll try to find another location just on the ribs only. I'm around, it's wider there by about 6/1000ths of an inch. Is that 7? 6/1000ths of an inch. All right, so that's just a little deformation. Let's try here. That's where the paint is. Now we're up to about 17 thousandths of an inch. 10 thousandths. Right about, I think that's 17. I'm looking at it upside down. You guys might see it regular, but I see it upside down. I guess now you see it differently. Yeah, 17. So we come down here, and we see it's actually where we're cut, and I'm actually under by 0.003 of an inch. I can't find any reports, studies to show where you cut rebar, does it deteriorate? Does it deteriorate and to what extent? So what I would do is I measure back until I get to my zero point again, and I'm not there yet. You'd have to bear with me. I'm not there yet. Zero. Trying to find zero. Non-shave morning. This won't be a shave. This will be a day off for me, so I can a couple days off, so I can let my face not get a razor on it. All right, somewhere about here is where I'm back to close to 0 point, and this measures. This one measures 6 inches. So 6 inches is from right about there to where my thumb is. Wait a minute. 5.5. Right where my thumb is. So we get 5.5 right. Yeah, that's not working, is it? Okay. Right about there, but I'm still not where this thumb is. So this thumb. Okay, hold on. This isn't working out. This is not. I need to get back to here. Yeah. Yep, I wear my shirts inside out sometimes. Don't advertise. I don't have time for advertisement. That's way back there around 10.5 inches. 10 3/4 inches. From the tip to there when I finally get back to my metal. 10 3/4. So from this end it's uncut. I come down. Well, I'm in my bend at that point, so I want to be fair. I want to get it before the bend, so we'll do it around 7 inches. Right around 7 inches. We'll take a measurement. Now this should be 0. Let me zero this out. Oops. Let me leave that where it is. It's too late. I got to recalibrate. So there's 0. Thereabouts 0. And then we come down here about 13 inches. It's off 1/10,000th of an inch right there. It's on this side. It's on this side. Let's see if I can get this right. It's on this side of the cut. This side is consistent without the cut. Now I'm going to call that 10,000ths off. Let's see, right about there. See me rock it, then I'll show you the numbers. And then I'll come right about there also. Right between the rib. Slide it off. It's about 5/1000ths off. 5/1000ths of an inch. Let's go into the rusted area. The bend. The bend, you nothing for free. You can't just bend something without it shrinking and contracting in different formats. That's about 10/1000ths off. So your dimensions change when you bend rebar. Your dimensions change. It's the compressive side, that's the tension side of it. But it still has to perform. So when you make your links, etc., you still got to perform. Yep. Pretty ductile. I mean, I felt a little bit of flex in it. Oh, you guys asked me to comment on the other engineer from, not the guy, but it's a guy. I don't know, Washington, Utah, or something like that. I don't know where he's from. Yeah, he's killed off the witnesses too. So, I mean, how can you take data from somebody who kills off witnesses? He kills off witnesses, and he keeps putting the location back to the face of the deck, and then by the building, and then he steps it back to the tributary area that I talk about, my butterfly area. But he doesn't talk about the BMA that was there at one point. This is not a one-off sample. There are two of my tests going on, and they were at the same time. They happened at the same time, and these two were in love with each other at one point. They were connected. So this steel is the same piece of steel, and I have two samples, then about approximately the same angle. Approximately the same angle, and I get to evaluate both ends of this steel. And so what I'm coming up with is that this one's coated. Okay, so that one's rusted, and the other one's coated in the center. And these ends have never seen another love like they never see before. Anyway, they're much more eroded, as you can see, by themselves. And that's that metal. But interesting again, it's the metal that was sheared, it was cut, that now deforms itself. How much does it go back? Shrinking, if you will, deteriorating, not swelling. This is just deteriorating. How much did it go back? And so without water, deterioration just through air, how much of it went back? Now here's the question. And the guy got it wrong. He said the metal's stretching. It's got a very limited ductility to it. Very limited. It's not the way it works. Let's see if I can get you a profile of it. See the flexing of it? And see it rebound. So it's got some. It does have. I'm messing up my desk, of course. It's got some ductility to it, some elasticity to it. But it cycles. I can't just keep cycling this. It'll keep wanting to go over and over and over. If I cycle it, it's going to want to take the new form that I cycle towards. It won't spring back. It's not spring metal. It will want to take the new form that I put it in, as you just saw. So it will want to take the new form that I put it in. It's not springing back. It's not spring metal. Now that was a compressive on this side and tension over there. So I think he says he's a structural engineer. I think he's misunderstanding the concept of how pullout matters with rebar, and that this shrinking, the restriction, well, it's not shrinking. With the removal of the materials, it's changing. I like shrinking. As it shrinks back, meaning it was larger at one point and the metals deteriorate away, shrinkage, it becomes smaller. Just like a man's thing, just a little bit of shrinkage. That's all we're talking about here, baby. We're just talking about shrinkage. Anyway, so when it shrinks back, if it's being gripped, right, and it shrinks back, it gets limp, it gets softer, it just slides out. But up here where it's larger and fully engrossed, it now can bond and hold. So if you pull on this handle right here. I'm sorry guys, it's hard for me to tell. I'm looking at, you see me as a full screen. I see a bunch of stuff on the screen. So it's kind of weird how I keep trying to position above something. I think you see full screen though. So if I grip this and I pull on this right hand, it pulls on the left hand. They're married. They're together. I'm using it, the stirrup area there. It pulls. Now inside it would be swelling, right? So it goes that way and this way. Now what's the one thing between that marriage is that what's causing the marriage to fail is not the concrete. It's pretty stable. It is this little lady here is doing it. Well, it's pretty stable. You get some water on it, you get some effervescence and salts. They actually can cause some fractures. They will cause some fractures in your concrete, whether you have steel in it or not. If you start getting the white efflorescence everywhere, they will expand. They will become, they're so hard, they will expand and they'll gain like a root of a tree, and they'll slowly lift up the sidewalk. Well, those efflorescence, so salts, they will expand and create cracks in your concrete. So here's the grip here. Now you can imagine if I don't change my diameter of my grip and I come down here, it's now doesn't have grip. No grip, right? So no grip. And so now you don't have this rebar working. We look at our samples. Let me show you a sample. We look at our samples and we've got fractured materials. Now you can imagine it just slides in and out. There's no grip there. There's no grip, but it's still held on the end, so it can have some flex inside this hole, if you will, that play, because there's no grip, so to have this exaggeration of the hole. But it's very small. Well, in this case, it didn't look that small, but it's very small. But you've got no traction there. You got no friction, baby. And this is how this works, through friction. No friction, and we're just having fun. We're not working yet. So to get that friction, the deck gets loaded. When it gets loaded, it moves that little bit, and all it does is hit the metal. There's no movement of the steel yet until it starts hitting the metal, and then pushes down, causing reaction trying to push it. But now the profile's changed of that steel inside the hole. It's got to be fully engulfed. Fully engulfed for it to work. Then they work together. If it gets loose, it just comes out. So you want the concrete to grab it, and now it works together. When it gets loose through the steel, jacking it off, making it loose that way, or through shrinkage, it will slowly lose its ability to hold. Now I'm just holding it just a little bit tight, just to give you an idea that it's still going to work, but not as good as if it was solid, then it will really work. But if it just loosens up a little bit, your reduction goes way down. And that's what's going on there. Now epoxies, they use epoxies and all. There's a few studies on that where the coatings, they fracture. They create slippage because they're coating at that point, and they can slip right off. The coating can. It can cause you some slippage right off the metal there, between your concrete and your steel, woman, man. So right on, oh gosh, right on the metal. If it helps it work, you guys remember it. You'll remember it. Now I can think of this. Give me some concrete. I want some concrete. Now it's a new way to ask for relations. Can I get some concrete? My steel needs some checking. So anyway, down here it's going to slip more, and down here it will not. I'm going to end that video with that because you can't beat that nastiness. Oh gosh. All right, bye.